A very good morning to everyone. Today we are going to discuss about the topic of McCulloch Pitts neuron, linear separability, Hebb's network. So first we are going to discuss about McCulloch Pitts neuron. This neuron was discovered in the year 1943. Usually it is called as MP neuron. MP neurons are connected by directed weighted parts. Activation of MP neurons is binary, that is, at any time step the neuron may fire or may not fire. So the activation of MP neurons is binary in the sense means we can able to fire the neuron. So that's activation of MP neuron is binary. And then weights associated with communication links may be excitatory, that is, the weights are positive, or inhibitory, the weights are negative. So the weight for neurons to get communicated is based upon these two things. One is excitatory and then the other one is of inhibitory. So excitatory is if you are giving up weight value as positive values, and then the inhibitory is the weight values which you are giving as negative values. And then the threshold plays a major role here. There is a fixed threshold for each neuron, and if the net input to the neuron is greater than the threshold, then the neuron fires. So here they are saying about when the neuron is getting fired, in the sense means the threshold value which is fixed for that particular network is greater than, that is, the actual input which you are giving, the weight which you are giving to the network or to the neuron is greater than the threshold value, then the neuron starts fires. So that's a role which is done here. And then they are widely used in the logic functions. And then the network of the MP neurons is shown in the figure here. A network which consists of the x inputs have been passed. So that is starting from x1 to x2, x3 up to x of n. And then from all those networks the input have been fed to the neurons. From all we are getting the weighted input that should be greater than the threshold value which is fixed for that the neuron to get fire. So if the value is greater than the threshold value, then the neuron will be started to fire, and then we will be getting the expected output. So this is what happens in the MP neuron. Here the weight, that is based on the excitatory weight, if a W is greater than 0, that is excitatory, and then inhibitory is the weight should be as the negative value, it should be as obviously less than 0, p value should be less than 0. The inputs from x1 to x of n possesses excitatory weighted connection, and it's from x of n plus 1 to x of n minus m as the inhibitory weighted interconnection. Hence for firing of the neuron it's mainly based on threshold activation function. So the activation function should be as a function of y of in equal to the function will be returning 1 if it is firing is y of in should be greater than or equal to theta, and then it returns 0 if y of in is less than 0. So this is about the McCulloch Pitts neuron. And then here the values for the exhibitory and then the inhibitory have been specified here. The threshold with the activation function must satisfy for inhibition to the absolute of about theta should be greater than nw minus of p, and then the output will fire. So when the neuron will be getting fire, in the sense means if it receives k or more excitatory inputs but no inhibitory inputs, that is excitator is the value should be the positive value it should get, so that only the value with the threshold value is greater than the value, the neuron will be getting fire and the output will be getting the output. That is the K value, Kw is greater than or equal to theta, greater than or equal to theta, and then again greater than K minus of 1 of W. The MP neurons has no particular training algorithm. The analysis, how far the analysis is performed is to determine the weights and the threshold. So by with these neurons we can analyze to perform how far the weight we are feeding over to the network, and then the threshold value will be greater than the input. That is the input value which you are giving should be satisfied with the threshold value which is greater than, to make the output to get fire. That is, you will be getting the desired output. It is used as a building block where any function or phenomenon is modeled as a logic function. And then next is about the linear separability. So linear separability, it is a concept where the separation of an input space into the region is based on whether the network response is positive or negative. So here the separations of the input space between the regions in the network response will be a positive or a negative. So that's a thing they are saying about the linear separability. The network response, how far the input space in the regions will be there to produce a positive network or a negative network. That is a response. They are saying that, and then the decision line is drawn to a separate positive or a negative response. So based upon the response which you are getting for a positive response as well as for the negative response, we will be drawing the line that is a decision line to separate both the positive and then the negative response. This decision line is called as the decision making line or decision support line or linear separable line. The net input calculation to the output unit is given as yin equal to bj plus summation of I equal to 1 to n xi wi. This region is called the decision boundary, and it is determined by the relation b plus summation of I equal to 1 to n xi wi equal to 0. And then here it's about the linear separability. The diagrammatic picture is shown here. So here how far we are getting the a positive response in a graph. Only the positive response we are getting only in the first quadrant. Other than that, the first quadrant, in all the quadrants, all the three quadrants, we are receiving the negative response. So when we draw the decision line over the positive response, only in the first quadrant it is matching it out. So this is the positive response which you are getting at the quadrant. With the positive response as well as with the negative response, when you are mapping it by drawing the decision line, it matches with the first quadrant. So that's what the explanation is given here by representing the figure. And then hence after drawing the decision line, by using this bipolar data representation, the missing data can be distinguished from mistaken data. Hence bipolar data is better than the binary data. The missing values are represented by 0 and mistakes by reversing the input values from +1 to -1 or vice versa. So and then the next topic we are discussing is about the hebb network. So in the hebb network, Donald Hebb stated in 1949, the hebb network is in brain, the learning is performed by a change in the synaptic gap. So whenever the change occurs in the synaptic gap, the learning is performed in the brain. So how far it's happening in the network is when an axon of a cell A is near enough to excite a cell B and repeatedly or permanently takes place in firing it, some growth process or metabolic changes takes place in one or both the cells, such that A's efficiencies as one of the cells firing B is increased. So here they are explaining the process of how far the learning is obtained through the hebb network. That is, whenever the synaptic gap between the cells of cell A and then cell B occurs repeatedly or permanently with any growth process or any changes in their places, then the learning is occurred. So according to the hebb rule, the weight vector is found to increase proportionately to the product of the input and then the learning signal, so that two interconnected neurons are on simultaneously. The weight update in Hebb's rule is given by W of nu equal to W of old plus x and y. It is more suited for a bipolar data. Hebb's network is more suited for the bipolar data. And then if you are using the binary data, the weight updation formula cannot distinguish two conditions, namely a training pair in which the input unit is on and the target value is off, another training pair in which the both inputs units and the target value is off. So this is the criteria which we used to follow in the hebb network. So totally we have discussed about the McCulloch Pitts network, linear separability, and then the hebb network. Thank you.